Hello.
Hello. I don't know if everybody just forgot about this meeting or had other plans or what.
I didn't join last week because I had a cold. Like, how many people were there?
We had like at least 6 last time, I think.
Oh, okay. Well, we can always ping on the APAC channel. I'll just post something.
Hello, everybody. Welcome to the Ruby Under a Microscope book club meeting on December 8th at 3 o'clock Pacific time. How's everybody doing?
Great.
Excellent. Cool. What did everybody think about the reading this week? Talking about, was it compiling and interpreting Ruby programs?
Did we want to record this one as well?
Mine says it's recording.
Okay.
Yeah, I think we're good.
I had a stupid question to open it. It was
Sure.
a pretty dry chapter.
Yeah.
in the table of YAV instructions, also, is it pronounced YAV?
Sounds good.
All right. Yeah, there was like a combination of snake-cased items and just single word things for the verb splitting. Like they have get local, but then opt underscore plus. And that seemed pretty weird. I was wondering if there was a reason for that.
I actually didn't notice that, but that is pretty weird now that you mentioned it.
Because then I thought maybe it was just underscore for the types, but then I feel like there was one that had, yeah, like on page 50 at the end there, you've got opt, send, simple in snake case, but then everything else is just single word. So I don't know. I assumed they were somehow different, but.
Good point. I don't have an answer. Might just be all questions.
I guess I will start because I put some question in the document
Okay.
agenda.
Sure.
So I read about the Ruby keyword, like you would introduce some extra YAF instructions. I thought it's really interesting. Like you would check for additional hash. I mean, you would check for keys in the hash, hidden hash. So it might have a performance impact, but I would still use it because this is pretty convenient.
Yeah, I noticed that too, that optional arguments and keyword arguments both looked like extra overhead where it had to look stuff up. But yeah, not sure. Like, I think they talked about that a little bit in the earlier group, which was actually last week. Just like whether or not it would make sense to do some sort of cache of the sort of bytecode that it writes. So like they kind of mentioned how Python has, I guess, .pyc files that it creates that kind of cache the sort of compilation of Python to whatever, and whether that would make sense for Ruby or not. And the conclusion was that there's probably not enough optimization going on in the compiler to make it worthwhile. But yeah, I don't know. I don't know how that affects like things like keyword arguments, where the more sort of sophisticated of features that they put in there, the more overhead you're going to incur probably using those sophisticated features. Any other thoughts on that?
Well, I just saw it's like, I think it's 4 extra instructions, and I don't, those instructions might not mean too much. So, I mean, compared to all the other things which can be slow, maybe this is slow.
Yeah, I'm sure the Ruby core team would have taken that into consideration when making the feature, how much it would potentially slow down a program.
Is it so the execution time of those instructions is the main concern, not extra memory of having them?
Probably both. I don't know. I don't know how long it takes to either compile down to those instructions, or once those instructions are compiled down to the bytecode that the VM understands, like how long it takes to actually run those instructions versus how much extra memory they might be taking up, or any sort of memory optimizations that might be possible if it sees other keyword arguments that are similar. I don't know if it can kind of like compress those in any way, but yeah, it's a good question. It's definitely getting into realms of things that I have no knowledge about whatsoever.
Same. It's pretty dense.
Yeah, I feel like my main takeaway was it's kind of almost a continuation of what was happening in the first chapter with tokenization, where it's kind of like we're just translating the Ruby code further and further down until we reach where it actually can run. And so this is just sort of an extension of that process.
Right, it's kind of the next step now that we've got these tokens and stuff. Like, what do we do with them?
Yeah, it's kind of like, well, we're not there yet. We got to do this first. We're not there yet. Still have to do this.
Yeah, which actually kind of makes me now wonder, how does it go from running your program as bytecode to now bringing you back the results that you expect to see? So I think we're probably going to go through that other side of the chain probably fairly soon. Once it runs, how do we actually present results that make sense to humans? So, yeah.
It was a very dry chapter, like you said. It did make me appreciate again kind of the magic of what happened with Ruby, where I was trying to think back to like the 1.8 to 1.9 migration. I don't remember any migration I had to do myself. It kind of just like swapped in, and now we were compiling everything and nobody even really noticed. It made me impressed with that again.
Yeah, that seems like it should have been a huge deal. But so it was not memorable at all. It's a pretty good sign.
Yeah, it was impressive.
So what I was kind of wondering is, since they started the chapter by saying Ruby 1.8, let's see, it basically like interpreted straight onto the C code, if I remember right. Whereas in Ruby 1.9, we had a virtual machine that we then create a sort of bytecode to the Ruby virtual machine. And I was wondering, is that basically just like a different type of machine language? Like, does the virtual machine allow you to have, like, to specify your own machine language that you're going to kind of compile down to? And I just thought it was really interesting that it's still, after going to the YARV instructions, it still has to interpret to C and then go to machine language. So I just feel like it was adding an extra step, yet somehow it sped things up, which is really interesting to me.
I have the impression that previously in 1.8, like we had this, what's it called, AST. It's like a tree structure where you can tell that the syntax are, I guess, nested under other syntaxes. But once we convert into instructions, I think there's no longer a tree structure. And how should I put it? I feel it's easy when we have a tree structure, so we know how we can traverse the trees, and we know like which one is dependent on which one. So we know the exclusion order by looking at the tree structure. But here, it's, I guess, flattened again. So it's just one long list of instructions which we will follow. And I just feel it's quite strange that I assume that we need a tree structure in order to like do the work. But here it's, we first convert the Ruby code into a tree structure, and then we convert it back to the flattened instruction set. So my assumption is probably not true.
Yeah, there were a couple lines in here. So I don't know what page this was, because for whatever reason, my Kindle book just has like locations, but not pages. So sorry, I can't guide you to the exact page, but it's under the heading Ruby 1.9 and 2.0 introduce a compiler. It's a few paragraphs in. It says the primary reason for using YARV is speed. Ruby 1.9 and 2.0 run much faster than Ruby 1.8 due to the use of YARV instructions. Like Ruby 1.8, YARV is an interpreter, just a faster one. So my question was like, why is YARV faster? Like, what makes it faster? So I don't quite understand that part still.
Right, it's like it introduced this step, but then that somehow made it fast.
Yeah, like how do you get away with that? Yeah.
I'm guessing like we follow the order one by one instead of traversing the tree makes it faster somehow.
But it still has that step first. That's what I don't quite understand. It still
That's probably an overhead where it will be faster for like one line of code on 1.8 or something.
Oh, I see. I guess that makes sense. Yeah. Yeah. And then my comment on this next one was just interesting because I didn't know what else to like say about it. But YARV is a stack-oriented virtual machine. And I was like, okay. Which means when YARV executes your code, it maintains a stack of values, mainly arguments and return values for the YARV instructions. So I kind of liked how they walked us through a bunch of examples of where it kind of showed like, okay, here's the receiver, and then here's the argument, and then here's the thing to call. And then next, we'll just take that as the new sort of receiver and call the next like sort of arguments and methods. And so sort of like stack that's growing, I guess, always using like, I don't know, some window of things in there to currently operate on, which is maybe why it's able to be faster. Like you said, it's kind of flattened back down to a flat structure. But yeah, I don't know, it kind of messes with my head. to think about all of that.
That is interesting that the note about it being a stack, because like we've started with text, we've taken the text, translated it from tokens, put those tokens into a tree, and then now turned that tree into a stack, which is read into C or whatever reads it after that. And so I guess like in terms of like the data structure complexity, a stack is much simpler than a tree. So that probably contributes to the speed improvement. But like as you mentioned, like you still have to read through the tree to make the stack.
Yeah, so it must just be easier to do that, especially in a sort of dedicated virtual machine environment, maybe where it's built specifically for that task.
Does that just happen once on startup, or that's any time the code is run that this is happening?
Good question. Because there's this dashed line arrow that says interpret between the YARV instructions and the C, and I'm guessing Ruby being an interpreted language, that feels like the point at which it's interpreting it. So yeah, maybe if you're in IRB and you write something, does it actually go through these top 4 things, then interpret it through C and give you back the results? Or yeah, like I guess, yeah, as you're writing lines in IRB, like what all processes is it doing every single time you hit return? That's a good question.
Yeah, I feel in IRB must have gone through those 4 steps.
Right.
But if we repeatedly run the same, I guess, script file, then it's probably only done once. And
on startup, yeah, like when you start a Rails server, then it does the compilation step, and then you have the faster runtime for your application, I guess.
Yeah. Yeah, and what's interesting about that is the idea of the development Rails environment versus a production Rails environment, where in production it caches classes, which maybe that's just the normal Ruby way of compiling it. Whereas in development, it lets you add things to a class and it will sort of reinterpret that on the fly somehow. So that's a really interesting notion. It must be like, I don't know, it's been a while since I've looked at that. Does it reload or re-require those classes if it detects changes? Does anybody know how that works?
I think the class is always like modifiable, so you wouldn't reload the class, but you will add stuff and override parts of the class when we define something again for the class.
Right.
But, I think there's a cache going on somewhere, but it can always be overwritten. For example, I remember that in OpenStruct, someone wrote a blog article saying that we should avoid using OpenStruct because every time we define a method in maybe, I forgot which Ruby version, then the cached method table will be invalidated. So Ruby have to regenerate a list of method tables, and it slows the application down. So I think that's part of the caching, but it can always be invalidated. So it's not a concern to add new things into the class.
Yeah, those are good points.
The thought that goes through my head is just like my JavaScript mind is like, oh, we're dealing with trees. Like maybe it's like React and you can invalidate part of the tree based on what changes, and that's what allows faster reloading because you don't have to recompile the entire tree somehow, but
Hmm.
I don't know. It's just a random thought.
Yeah, that's an interesting thought. I feel like, so like, I guess my example would be if you just write a plain Ruby file and you kind of load that up through, Ruby, run whatever file, and it's just sort of like, maybe it runs through your program and it has sort of a read eval print loop type thing going on in it. While that's running in the console or in the terminal, you can't go into the file, make changes, and expect those changes to show up in your live running program, right? Like it will have already gone through those 4 steps, interpreted the whole program, and then run it. And just because you changed stuff in the file in the meantime, it's not going to automatically reload that stuff through the same 4 steps and sort of recompile your program to an extent, or reinterpret it, I guess.
Yeah, that makes sense.
I think yes. To my impression, I feel you changing the file and Rails automatically reloads the file is like a Rails specific thing. So,
It is, yeah.
Yeah, so probably if we only run Ruby without Rails, it wouldn't auto reload the changes.
Right. That's kind of what I'm thinking. So that's probably why development is so much slower, or at least always perceived as slower, because it's constantly sort of reloading files. And I'm wondering if it just like always reloads files every request, or if it only does it if it detects a change to a file. But anyway, yeah. I'm sure that someone could find a way to attach something to one of these steps that would like output a counter so you could actually see what's happening each time, but it's not me. I also thought it was really interesting going back to kind of the keyword arguments and that whole line of thought about optional arguments and block parameters and the rest arguments, all of that stuff. It's kind of interesting that it sort of just added them on. Like arg feels like the thing that was there has always been there. And then these other ones were just sort of like an afterthought, which is maybe just exactly how it happened. But looking at like the local table example, where it has like size 2, argc1, and then it has like square brackets for ops, rest, post, and block. And I was really curious what -1 meant in those contexts. Like, what is that telling us? But anyway.
Yeah, I think the keyword arguments is one of those things that was very much like an afterthought, and they kind of seeing how they had to implement that. It seems like it was a little hackish. I'm not saying there's a better way to do it, but yeah, that was just like they worked it into the design of the language after the fact.
Yeah.
I'm very glad they did.
For sure.
A lot nicer to use keyword arguments, especially once you get over like 2 or 3 args to a function. It's like, just let me name these things already. Yeah.
I see what you're talking about now, where it says like block -1. I wonder if that means there was no block supplied.
Right. Yeah, that like I feel like sometimes it says 0 and sometimes it says -1. And I don't know if both of those mean nothing supplied, or I don't know.
Does that happen anywhere except for a block? Because I feel like that's, oh no, I see rest -1.
Yeah, rest has it too. I'm trying to remember which thing were they compiling in this one. Oh yeah, the 10 times do inputs in. Huh. I don't know. It's a mystery. Cool. Well, I think we are over time for our get together today. It was great to see everybody, and see you all again next week, or maybe some of you. I don't know. See how it goes with holiday plans and all of that. But
Kind of hoping the next chapter is more than just a bunch of tables.
Right?
yeah, more tree structures. Woohoo. Yeah. All right. We'll see you then. Take
Bye,
care.
everyone.
See ya.
Bye.